So example B talks about Gloria depositing $2,000 into a bank account. So that's the very first day she walks in, boom, $2,000 in the bank. How much time in years have passed since she put the money in if she's still there at the bank putting the money in? 0. So this is a case. The instant where the instant that she puts the money in the bank, she's at U0. Do you get that concept where we're not using U1, but 0, because 0 time has passed when you're at the beginning. And that initial amount would be 2,000. Now, they didn't ask us to use a formula here, but I want us to practice it and make sure that we understand how to write the formulas. Every year, they're going to give her 7% simple interest, or compounded annually. But what that means is, at the end of a year, they're going to give her 7% more than what she had in there. Okay? So we talked about this a little bit in the past. If you put your money under the mattress, right, and you leave it there, it's not a really good savings account because it's not earning interest. So if you start with $2,000 under your mattress and then you leave it there for a year, guess how much is going to be there after a year as long as no one steals it? $2,000. You will have 100% of what you had, no more. That would be a 0% increase, right? Having 100% of what you had meant that no change has been made. But if you're going to get 7%, you will then have 107% of what you had before. The 100% plus 7 more. Do you get that? So now we need to convert that to a decimal that we can use in this word problem. And 7% growth would be what as our growth factor? 1.07. That's going to be your R, your common ratio, what you multiply by. So the rest of the formula would look like this. For you to get to the next year's value, UN, you would take what you had the year before, which we call what symbol? U, N minus 1. You don't take away $1 from her bank account. That's not what the N minus 1 means. It's representing the term before the term you're on now. And you multiply it by 1.07. That's how you get from year to year. So to answer the question, when will the original deposit double in value? Our question is, when will she end up with how much money? $4,000. After how many years? So that's where we're going to go to the calculator, and we're going to start getting the ball rolling here by typing in 2,000, enter. You might want to clear the screen and start with a fresh screen. So press 2,000 and hit enter. This is the simplistic way of doing these problems. This is the straightforward, easy way, but it might take some time. And the only place you can really mess up is if you hit a wrong button, or if you lose track of how many times you hit enter to do a problem like this. 2,000 is what we start with. And we are going to learn shortcuts. We are going to get to other methods, but we believe in starting with, what is this all about? Why do the shortcuts work to get there? So you start with $2,000 times 1.07. This is what she would have after 1 year. That makes sense, because 7 times 2 is 14, right? So you see that 2140, 140, that's that 7% increase. That's after 1, 2, 3. When should I stop? 4, 5. All right. 6, 7, 8, 9, 10, 11. It'll take 11 years for her bank account to double in value. Is there a formula? Yes. Might it involve exponents and stuff? Yes, especially when it's geometric. So we're going to get there as the year goes on. But for now, with geometric, we're going to hit enter and count how many times it takes to get there. All right?